So I'm really excited to be here with you tonight to talk about all sorts of gas giants. And it's a special time because Jupiter is up in our own night sky. And that leads us to wonder both about Jupiter, but also about Jupiters that are orbiting other stars and what mysteries those other worlds hold as well. But before we go and journey to these very distant worlds, let's start out in our own solar system, or even at our own kitchen table. So many of you or your children may have had to make a model of the solar system like this, and it has the sun in the center, and then orbiting close to the sun are the terrestrial planets, Mercury, Venus, Earth, and Mars, and then further out are the giant planets, Jupiter, Saturn, Neptune, and Uranus. And actually, a picture like this tends to give us an exaggerated sense of our own importance. Because if this is the size of the sun, the Earth would just be a tiny dot in comparison. Do you see it? It's just right there. So our solar system is really dominated by the gas giants, but especially by Jupiter. In one way of looking at it, Jupiter is really the most important planet in the solar system, not the Earth. Or at least I'll try to convince you of that today. But let's take a closer look at Jupiter. So here's Jupiter spiraling into view, and you might think of the planet Saturn as being our solar system's ringed planet, but Jupiter actually has its own set of rings. They're more tenuous, but they're still there. And it also has these beautiful bands, and what the bands are frozen clouds that are stretched out by Jupiter spinning. And even though the bands look really beautiful, unfortunately, they would smell really bad if you were there because they're made of methane and ammonia, so they smell like rotten eggs and window cleaner. So we should be glad that we can't smell things through the telescope. So now if you look in the corner down there, you can see Jupiter's giant red spot spinning into view. And what this is a giant hurricane that's a few times the size of the Earth. And we see big storms like this on other giant planets too, like on Saturn and Neptune, but only on Jupiter have we seen this giant red spot raging ever since the time of Galileo. So ever since people first looked into the telescope, they've seen this same hurricane that hasn't gone away. So what did it look like when people first looked through the telescopes in the 17th century at Jupiter? Well, Galileo was one of the first people to do that, and what he noticed is that Jupiter is orbited by its own set of small moons, which you may be able to see when you look through the telescope tonight. And the fact that these moons were orbiting around Jupiter led him to start to question the idea that everything orbits around the Earth. And eventually he got into trouble by questioning that idea. Cassini also looked through the telescope and noticed these spots and bands that you might see when you look tonight. But actually, when we look at the telescope at Jupiter tonight, we'll know some things about Jupiters that people never would have guessed in the 17th century or even in the 1970s. And that's when you go out and look tonight for Jupiter, if you're trying to spot it, it's up in the constellation Taurus, so above Orion. You'll also see that there are so many other stars in the sky. You might wonder if they too have their own Jupiter that's orbiting them or their own solar system. And if they do have their own solar system, does it look like this solar system that we've constructed at our kitchen tables, or is it something completely different? So people started to go out and look for these solar systems that are orbiting other planets. So this is a picture of Lick Observatory in California with the moon rising behind it. And at this observatory in about 1995, one of the first extrasolar planets was discovered. So an extrasolar planet is a planet that's outside our own solar system and is orbiting its own star as its sun. So people started to find these extrasolar planets, and actually what they expected to begin with is that the first thing they would find is something like Jupiter, because Jupiter is the biggest planet in our solar system and it's the easiest to detect. So they thought maybe something like Jupiter would be the first thing to find that's far away from its star, and we could see a Jupiter analog orbiting another star. But instead they found something that was very different from Jupiter. So they found giant planets, but instead of being really far away from their sun like our Jupiter is, they were orbiting extremely close to their sun, like this cartoon shows. So there's Jupiter-sized planets, but instead of being out far away from the sun, they're right next to the sun at temperatures of thousands of degrees. So being really creative, astronomers called them hot Jupiters and started to find a large number of these hot Jupiters and that they really had mysterious properties. So some of these Jupiters get so close to their sun that they actually have a tail of material evaporating off them just like a comet does. And that seemed really exotic, but it turns out that in our own solar system, Venus has a tail like this streaming off it, but it's too tenuous for you to be able to see with your eye. And people have also found a planet that's evaporating. It's almost evaporated away because it got so close to its star. And I think that would be even worse than global warming. Another type of strange weather that you might see if you lived on one of these hot Jupiters is that it gets so close to the star that when rain falls, instead of the rain being made of water, it's made of liquid iron because it gets so hot like that. So if we expected to find something like our own solar system, we failed to do that. And in fact, if you think of the closest planet to our sun, which is Mercury, and we draw the scale, so in the center is the sun, and this blue line is Mercury's orbit going around the sun, if we had a hot Jupiter in our solar system, it would be 6 times as close to the sun as Mercury is. So this type of planet, these hot Jupiters, are really like nothing we have in our solar system. They also astonished us with some of their other physical properties, like their size. If this is the size that we expected Jupiter to be, hot Jupiters have been inflated to twice the size of normal Jupiters, and that's because they're getting so strongly irradiated by being close to their sun. So these Jupiters were a huge surprise. No one expected to find any of these hot Jupiters, and their properties are completely astounding and different from our solar system. They're large temperatures, they're huge sizes, and the strange weather like iron rain that they would exhibit on these planets. So one thing that we know is that in these extreme conditions, there's no way that Jupiter could have formed there. That's why it's so surprising to see it there. This is not where planet formation can take place. So let me just tell you a little bit about how a planet forms and why a hot Jupiter wouldn't be able to form as close to its star as we observe it. So here we're taking a view of just an area of empty space, but it's not empty because it has stars, and it also has these pink streams you see, which are gas. So this is where the planet formation begins. Now we're starting to zoom in on one of these clouds, and this is like a nursery for forming stars and for forming planetary systems because it has all the material available. And then what needs to happen is the gas needs to get more dense, like this dense cloud, and then collapse down. But instead of collapsing into a ball, it collapses into a disk, sort of like when you throw up a ball of dough and spin a pizza into a disk. It's spinning, so it makes this flat disk, and all the material is being funneled onto the star. But orbiting the star is all the gas and dust that came from the cloud that it formed from, and then this is the material that is used to form the planets. So in order to form a giant planet, what you need is to be at a cold enough location where you can have icy solid materials form into a giant core. And then that giant core is going to be able to accrete gas from in the disk. So now we're zooming in on a newborn planet, and this rocky material comes together to form a core, and then the Jupiter is so large that it can start to pull gas from the disk and end up as one of these giant gas planets. But this cannot happen if you get too close to the star, because then there's not solid material available for you to form the giant core. So that's just how we know that Jupiters need to form out far away from the sun, like where our Jupiter forms. And if we see them closer, like these mysterious hot Jupiters, they must have somehow moved in from where they formed to where we observe them today. So that's actually the subject of my own research, is trying to figure out how Jupiters moved into their close-in mysterious orbits. And there are actually two theories for doing that. One is a more gentle way. So you have the Jupiter forming in this very gassy disk, and the disk can push the planet in to be close to the star. So it's just moving gently through the gassy disk. The other theory is that after this gassy disk evaporates away, then you have all these giant planets that formed, and they're no longer cushioned by the gas disk against each other's gravity. So they start to feel each other's gravity, they don't like each other, and they scatter each other and knock each other around, and some of them may get sent in very close to their sun and become a hot Jupiter. And this is a more violent mechanism for forming hot Jupiters, or it could be the gentle one. That's what we're trying to figure out. But regardless which of these mechanisms is moving the hot Jupiter to be so close to its star, it's a very bad situation for any Earth-like planet that formed between the hot Jupiter and the star. So planets like this are really in trouble if you're moving in the Jupiter to be in their place. So I'm going to show you a computer simulation of what could happen to Earth-like planets as the giant planet moves in. So let me orient you here. We have a flat disk with planets in it. Those big black balls are the giant planets, and then we have small planets and asteroids outside of them. And when I start the simulation, this is now the gas disk is gone, things aren't cushioned anymore, and they can jump around and get excited out of the disk that they formed from. So you're going to see that happen. Look how excited the small planets and asteroids are getting. They're really not very happy about this. The giant planets seem okay for now, but Christine was reminding me that this looks like a popcorn popper. That's the sort of push cart that children have that makes the popcorn pop up. It's like in a bubble. I don't know if any of you had that, but it really resembles that. And so that's not good if you're a terrestrial planet. So now I'm going to play some more of the movie, and I want you to focus on these close-in planets that might be like the Earth. They're close to the sun, and what you're going to see is that they'll start to disappear. So what's happening is that some of them are being sent into the sun, some of them are being completely ejected from the solar system, but eventually they're all going to disappear because they can't stand being excited so much. And now what I want you to look at is what's happening to the big black giant planets. They're going to suddenly have some really strong interactions. So go ahead and watch. So, oh no, they're gone. So the vertical scale could extend up to about 90 degrees. This is more of a schematic view, but things can really get quite excited through these scatterings. And you can see that now all of the Earth-like planets are gone, things are getting cleared out, and you're left with a giant planet that's really close to its star, but any small planets have been removed from the system and are in trouble. We're left with something that doesn't look at all like our own solar system. It's just two giant planets all by themselves. So this did not produce something that looks like our own solar system, and maybe we should be glad that something like this didn't happen here, that we don't have our own hot Jupiter, because if our Jupiter had moved in to be so close to the sun, we wouldn't have survived that. And you might think that our own solar system was a relatively calm place then and didn't have so much upheaval, but that actually isn't the case either. We think that something similar happened in our own solar system, just not on quite such a catastrophic scale. So what we think happened is that our own solar system's giant planets started out much closer together than we observe them today. They felt each other through these gravitational interactions, and then Neptune and Uranus moved out through these interactions into the more outer part of the solar system. And Jupiter itself even moved around, but it only moved around a little bit. So we didn't have this sort of catastrophic ejection of Earth as we saw in some other solar systems. So this can actually be a good thing to have Jupiter moving around. Let me show you a movie. So as Jupiter is moving around in the early solar system, it's moving around the asteroids that are nearby it. So some of these asteroids are being ejected out of the solar system, but other ones are coming towards the Earth. That actually seems really bad. You have all these asteroids coming in, and some of them are hitting the Earth and delivering material, but that's where it becomes a good thing. So this is what's known as the late heavy bombardment, when we had all these asteroids sent towards the Earth and the Moon by Jupiter. And as they impacted the Earth, they did probably cause a lot of damage. This is before life had formed, but they also may have delivered a lot of the Earth's water. So it could have been a good thing to have these coming from the outer solar system. So here you can see in the movie, things are delivering not only rocky material, but gassy water that may be the reason why we have so much water on Earth. So even though it sounds like a terrible event, it could have had some positive consequences for life too. So we can sort of think of Jupiter as being this big bully of our solar system. In fact, Pluto is on this very tilted orbit, and we think that also happened during this early period of instability when all the gas giants were moving around and strongly interacting with each other. Pluto got tilted onto its odd orbit today. And even though Jupiter is sort of like a bully of the solar system, I like to think of it more like an older sibling, like a big brother, because even though it bosses us around and can sometimes even cause a bit of damage, it protects us when something else is trying to boss us around. It's not going to stand for us to be injured by other objects in the solar system. So let me show you an example of that. So in the early 90s, there was a comet coming in from the outer solar system called Comet Shoemaker-Levy 9. And instead of going towards the Earth as it might have done, Jupiter, being so huge, can gravitationally focus the comet to come towards it instead. So then there are all these giant impacts on Jupiter caused by this comet. And that was actually really exciting to watch, but wouldn't have been so good if they were impacting the Earth instead. In fact, the cool thing was that we got to take some pictures of this as it happened. So these are some pictures from a telescope on Earth. And what you can see in the top corner up there, do you see those small black circles? That's the string of comets that is impacting Jupiter. So these are photos taken at the beginning, and you can see the black circles moving across and moving across. And so we heard about the meteor impacting the Earth in Russia. That was only about 50 feet across, but each of these is about a mile across. So if that had come in towards the Earth, we would definitely not be here today. So it's actually great that we have Jupiter far out in the solar system. With all its gravity, it tends to pull comets to become close to it, and that could have been sent in to the inner part of the solar system. So that's a great thing about Jupiter. And really, when it comes down to it, even though these giant planets that have been discovered around other stars, these hot Jupiters, are so interesting, and I as an astronomer love to study them, I'm really glad that we live in a solar system that looks more like this, where we have a giant planet that did move around a bit at the beginning of the solar system, but not enough to sweep us away or eject us from the system, just enough to send in some asteroids that may have brought us a lot of our water. And now it's standing in the outer part of the solar system, protecting us from comets and other bodies that may come in and harm the Earth. So I think that when I go to the telescope tonight, I'll want to say thank you to Jupiter for being such a great big brother. Thanks very much.
Thank you, Rebekah.